All right, today we're going to take a little break from all that graphing you've been doing so well over the last few weeks. And we're going to talk about describing number patterns. When we're talking about number patterns, we're talking about some of those things that you've seen growing up where it says, like, name the next three terms in the pattern. Okay, we're going to take that and we're going to take it a step farther. Okay, and throw a little algebra twist into it. So we have some vocabulary in this particular section that is very important to know. The first word is inductive reasoning. Inductive reasoning is making conclusions based on patterns you observe. So this whole idea of filling in the next couple numbers in a sequence is actually specifically called inductive reasoning. You're making some very real conclusions about patterns you may see. Okay? All right, the next word we have is a conjuncture. A conjecture, sorry, excuse me, is a conclusion you reach using inductive reasoning. So once you're using that inductive reasoning, you then get a conjecture. Okay? All right. So the next vocabulary word is kind of encompassing this entire slide. It's a sequence. A sequence is an ordered set of numbers that follows a rule. All right? So for example, 1, 2, 3, 20, 25, 30, 35, 100, 10, 1.1, or 1/10. Okay? 3, 9, 27, 81, 1, 1, 2, 3, 5, 8, so on and so forth. Okay? Within all of these different sequences, there's actually two specific types that you're going to be looking at some point during your math career. There's the arithmetic and the geometric. And today what we're going to be focusing on is actually the arithmetic one. Okay? And the arithmetic one is a sequence created by adding the same number repeatedly. Okay? So for example, 5, 7, 9, 11. Okay? You're adding 2 each time. 7, 3, -1, -5. In this case, you're subtracting 4 each time. Or you could also look at it as adding -4. Okay? So you could look at it as subtracting 4 or adding -4. Okay? All right, and then this one we have -3, 2, 7, 12. I want you guys to do this one in your whisk tonight. Figure out what's the pattern here. Okay? All right. So with these arithmetic sequences, in order to make our life a little easier, because oftentimes the question will come across and it'll ask you, what is the 50th term in this sequence? Well, instead of listing out 50 numbers, algebra has given us a wonderful formula or an equation that we can use. All right. So, the first thing, so when we're writing an equation for the nth term or an unknown term of an arithmetic sequence, they always tend to use n for when you're talking about a specific number in a sequence, and probably standing for number. It's just always how they do it. Okay. So the first step, and this will all make sense at the end, is find a 1. Okay? Then you want to find your D. Then you're going to plug the values into this equation. And this equation is the equation that I was talking about, this one right here. Okay? It's very, very important. Write it down. It is your arithmetic sequence equation. A n equals a 1 plus n minus 1 times d. All right? This meaning that A1 is your first term, okay? N is the term number, and D is our common difference, meaning the common difference meaning that as your how much it's going up or down by, okay? So specifically, if you had like 2, 4, 6, 8, okay, you're adding 2, so it would be 2, okay? All right, to continue with that, with our steps here, we then have distribute the D, simplify by adding like terms, and now you have an equation to find any value in the sequence, okay? So, for example, we want to find a specific term. We know that now that we know this particular formula, we can find any sequence. So let's say my first term is 4. Okay, my difference is 6, and the term I'm trying to find is 14. And I'm solving for whatever nth term I'm trying to find. All right, so I can just plug this into my formula. So I have a to the n equals 4 plus my n, which is 14, minus 1 times my d, which is 6. All right, use my order of operations. So I'm going to do the stuff inside the parentheses first. So I have 13 times 6. 13 times 6 is 78 plus 4. And my solution should be dun, 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 82. All right. All right. I can do the exact same thing with this type of, with this problem, okay? I'm not gonna bore you, but it's pretty much the same. Just make sure that when you are doing it when there's negative numbers involved, um, please make sure that you include, that you pay close attention to the negative numbers, like I always say, okay? But if you could do number 2 in your WIS tonight, that would be very good, okay? All right. Okay, that's all I have for you about describing number patterns in specifically with arithmetic sequences. Please come to class with any questions and have those 2 problems done for me in your WISC for tomorrow. All right, thanks.